Okay, today we're going to learn how to write half equations. Okay, now what is a half equation? Well, you can always spot a half equation because, as opposed to a normal equation, it's always got electrons somewhere in it. Okay, it's always got E minus. Another little rule about them is it's the oxidation state of only one element must change and must be one element only. And then the usual thing, they must be balanced. And that means they must have the right number of charge, not only the right number, balanced number of atoms, but it's got to have the same charge on the left as on the right. Now, don't worry about this for the time being, but you're going to use this little method to write half equations. But I'll just get rid of that for the time being. Oh God, right. So now what we're going to do, right, so I'll just give you a couple of examples of half equations, ones that you've probably seen already and that are quite easy to understand. So you might see, I think we had in a previous video, we had Cu 2 plus turn into Cu. Now, to balance the charges there, we've got 2 plus on the left and 0 on the right, so we've got to put 2 electrons in there. Okay, so that would show you that copper is being reduced because it's gaining electrons. Okay, its oxidation number is going from +2 to 0, and that's why it's 2 electrons. Okay, let's have a look. It's quite a simple one. We have, say, Cl2 going to form two chloride ions. Okay, so and then that would have to be the electrons on that side, yeah, to make the charges balanced. So each chlorine atom is gaining electrons to form a chloride ion. Its oxidation number goes from 0 down to -1. That's very straightforward. You might see another one, which is a bit more difficult, say something like hydrogen peroxide goes to oxygen, 2H plus and 2E minus. Okay, so that is less familiar to us. Let's just, right, you've got the oxidation number of only one element to change. So hydrogen is +1 and +1 there and +1 there. That doesn't change. The oxygen is -1 there, and we know the oxidation number of oxygen as an uncombined element is 0. So the oxygen has actually it's gone up. It's been oxidized, hasn't it? Okay, and just the charges balance on both sides of the equation. Yeah, you've got 2 minus plus and 2 plus here, so that's 0, and that's 0 on that side as well. So that's all good. Some people might be tempted to write, instead of that, they might be tempted to put H2 or something in there. Now that wouldn't be a half equation because we've broken one of the rules. We've changed the oxidation number of 2 elements there. The hydrogen is +1 and it's gone to 0 there, as well as the oxygen. So that is not a half equation. So that is definitely wrong. Okay, so you never do that. Okay, so I think the best thing to do is, is to do an example so we can understand what's going on. And half equations are very useful because you can combine 2 half equations, stick them together into a full equation, and it's quite an easy way of writing an equation and being able to understand what's going on there. Right, so what I'm going to talk about now is a reaction. So if you get a beaker and you put a copper coin in the bottom of the beaker, and you add some concentrated nitric acid, not dilute, it's going to be conc HNO. Okay, shove that in there, and what happens is it fizzes up and you get all these brown fumes, which you've got to do in a fume cover. It's pretty poisonous, and the brown fumes are of nitrogen dioxide, NO2, and what happens is the coin dissolves and it will form a blue solution here, solution left over is nice, lovely dark blue color, and you probably recognize blue solutions. That is because you've got copper 2+ ions in that solution. Okay, so we're going to write some half equations, two half equations for that. It is a redox reaction. You can probably see, or for a start, the nitrogen there is +5, and the nitric acid is only +4 there. So that's become reduced, hasn't it? And the copper coin, well, copper coin was 0, but when it's formed the two, it's obviously a +2 oxidation state there. So the copper's been oxidized by the nitric acid. So we're going to write down an equation for that. So I'm going to write down, first of all, the nitric, what's happening to the nitric acid. So you're going to have HNO3, and that's going to turn into NO2. So I'm going to follow my list here now. This is what we're going to do, follow this list of what to do, writing a half equation. So first of all, we've got a balance for the element of interest, and the element is nitrogen. We've got one nitrogen there and one there, so we don't need to do anything. That's fine, that's easy. Number two, we've got to balance the oxygen atoms by adding H2Os. Well, I've got 3 oxygen atoms there and I've only got 2 there, so that means I need to put an H2O there. The next thing I need to do is balance the hydrogen atoms by adding H+ ions. So I have got, I've got on the left, I've got 1 hydrogen, on the right I've got 2, so I need to put another H+ here. And then number 4, I've got a balance for the charges. So on this side of the equation, I've got +1 as an overall charge and 0 on that side. So to make it the same, I need to add electrons. Okay, so where I'm going to put the electron, I'm going to put 1 there. Okay, well, you've got, okay, 1 electron there. So everything's balanced now. So that is our complete half equation. All we need to do now is check the oxidation numbers, and this is a not essential step, but just to make sure everything's working okay. Now the oxidation number of nitrogen there is +5, and the oxidation of nitrogen there is +4. So that means it has been reduced. So what should it be doing with electrons? It should be gaining electrons. And how many electrons? Well, because it's gone from +5 to +4, that's 1 electron, and we have got 1 electron there. So number 5, the whole thing works. So that equation is spot on. Okay, so we've written our half equation successfully for that half. Now we need to think what's happening with the copper. Right, copper started off as Cu, and it ended up as Cu2+. So balanced for the element of interest, well, one copper, that's fine. Balance the oxygens, easy, there aren't any oxygens, so forget that. Balance for hydrogens, there aren't any, so forget that. Number 4, balance for charges. Yeah, we need to do that. We have got 0 on this side and +2 there, so I need to put 2E- on that side of the equation. And finally, check the oxidation numbers. So we've gone from 0 to +2, so it's been oxidized. Oxidation is loss oil, so has it lost electrons? Yeah, it's lost that meant them. How many has it lost? It's lost 2, and it should have lost 2 because it's gone from 0 to +2. So we've successfully written the 2 half equations now. Now we have to combine those 2 to make a full equation, and that's pretty easy. All we need to think about is, right, this one here is giving away 2 electrons. But this one is only using up 1 electron. So if we're going to combine them, we have to say that this one goes forwards 2 times, so every time this one goes forwards just once. Okay, so now we have to times this equation by 2 and add it to that one. So here we go. So we've got 2HNO3 and 2H+, plus we've got copper, so that's all the products sorted out. Well, let's put the electrons in as well, even though they'll cancel out afterwards. And then on the product side, we've got 2NO2, 2 H2O, 2 copper 2 pluses, just one copper 2 plus, sorry, and 2 electrons. Right, obviously get rid of the electrons, that's the whole point. So it's a full equation now, electrons don't appear in it. It is a full equation. This is our full equation, okay? And it is a full ionic equation. It's not a full equation, and a lot of people are quite suspicious of ionic equations, even though they are, you'll learn to love them because they let you see the wood for the trees. But if you just wanted to think, well, what is the full equation? Well, let's think, what's the spectator ions here? We've got H plus. What's going to be the spectator ions for H plus? Well, it's nitric acid, so it's going to be NO3 minus ions. And how many? We're going to need 2 of them, aren't we? Yeah. Here, the copper, right, that's going to have some negative ions to go with that copper. And it obviously is going to be those nitrate ions, NO3 minus. So if you, and there's going to be 2 of them. So if you did want to write a full equation with not ionic, you'd write down there, right, 2, that's going to give you, right, those 2 nitric acids and these 2 nitric acids, so that's going to be 4HNO3 plus copper goes to 2 NO2s, water, and copper nitrate. So that's where you put the spectator ions in, but this is the best. That is definitely better to have that. Okay, in the next video we'll do a few more examples of using this set of instructions to write half equations, and then we'll stick them together to write the full equation. Okay.